Hi everyone. So in this video, we're going to work through a Year 12 mechanics question from the AS sample paper. Now, this question is about variable acceleration. So in other words, acceleration which is not constant. Now, remember, if the acceleration is not constant, you cannot use Suva equations. You have to use calculus, either differentiation or integration. So with this question, a bird leaves its nest at time t equals 0 for a short flight along a straight line. The bird then returns to its nest. The bird is modeled as a particle moving along a straight horizontal line. So if you've got a particle moving along a straight horizontal line, this is one-dimensional motion, so 1D motion. The distance s meters of the bird from its nest at time t seconds, so in other words, this s is kind of like the displacement from the nest, is given by s equals 1 over 10 and then multiplied by t to the power 4, subtract 20t cubed plus 100t squared, where t is between 0 and 10. So part A to the question says, explain the restriction t is between 0 and 10. But just before we get into the video, I want to make you all aware about a web app that I have created. Now, this app that you see on the screen here is designed to predict the 2027 Edexcel A-level Maths topics that will come up in your 2027 exams. So now that the 2026 exams are finished, we now have access to those questions. So what I've done is I've analysed all of the questions from 2026 back to 2018, and also including the sample and the specimen Edexcel papers. And I've used that data to put together a model which will predict the topics for the 2027 exams. And if we just scroll down here, you will see how accurate this model that I'm using is. So if you do want to have access to the full predictions for the 2027 exams, and also have access to a web app which will generate mock exam papers based on these predictions, that is what you can get if you do sign up to this app. Just go to the link in the description of this video, and also you can get the link to this web app in my bio. Click that link, sign up. You can see on the top right of the page here, you can sign up to the app, and you'll be able to access all of these 2027 predictions. Okay, so if we just draw a rough diagram just so we can visualize really what this bird is doing. So the bird has a nest there, let's just call that nest. And then the bird is kind of moving in a straight line forwards, and then the bird is moving straight back to the nest. Again, that's kind of what's happening in this situation there. Now, if we investigate this formula for distance from the nest, so this S formula, it makes sense to try and factorize it. If we can factorize this displacement formula, which is a quartic expression, then we can kind of get a sense for the distance, and maybe we could sketch the graph of this distance against time just so we can understand really what this bird is doing. So hopefully you can notice we can factorize out a t squared like so, and that leaves us with a t squared minus 20t and then plus 100. Now, with that quadratic factor, hopefully we should be able to factorize that, and I think we can if we put two pairs of brackets there, a t there and a t there. We're looking for factors of 100 that add up to make minus 20, so minus 10 and minus 10 again. So in other words, we can say that this is 1 over 10 t squared and then t minus 10 all squared. Now, if we were to sketch a graph of distance against time, let's put the distance up there, let's put the time over there. Hopefully you'll realize that this quartic has two roots. Okay, so it's a quartic expression or quartic function. You've got two roots, and actually these two roots are repeated. So hopefully you remember from pure maths that if a factor is squared, that leads to a repeated root. So t equals 0 is one repeated root, and t equals 10 is another repeated root for this quartic. So you're going to have a root at t equals 0, a root at t equals 10, like so. And if we were to sketch this quartic, because the t to the power 4 coefficient is positive, it's going to look like a W shape with this one. So hopefully you remember your sketches for quartic curves. So it's going to kind of look something like that. Not the best graph in the world, but the graph is touching t equals 0 and t equals 10, like so. Now, in the context of the question, remember we've got the bird that is at the nest, and then the bird is traveling forwards and then traveling backwards to the nest. So if we use maybe a different color to explain this, the bird is starting at the nest here, The bird then travels forwards, and then the bird travels back to the nest. Now, because after 10 seconds, the graph is suggesting that the bird leaves the nest, then obviously that means that t must be between 0 and 10. Because if t was bigger than 10, then that would mean the bird would fly away from the nest again. So we just have to explain this in words. So I'm going to try and do that down here. So I'm going to say clearly, so clearly from sketch of s equals 1 over 10 t squared, t minus 10 squared. Well, let's just start by saying that we cannot have negative times. We cannot have t less than 0. That's obvious. You can't have negative time in these mechanics questions. And also, if t is greater than 10, let's write this down here. If t is bigger than 10, then clearly the bird leaves the nest for a second time. But in our question, we're told, sorry, let me just rub out that line that I've drawn there. We're told that the bird leaves the nest once and then returns with no motion after. So therefore, t must clearly be between 0 and 10 for this question. Hopefully that does make sense. If you explain your answer relatively similarly to how I've done that there, then you'll be fine for this question. Just another quick interjection. If you are currently doing Edexcel A-level Maths and you feel that you're struggling or you're falling behind and you're not quite getting that grade that you need to get in order to get into university, or perhaps you're a parent watching this and you're worried about your child's progress, what you can do is you can head to my website. Now, my website is in my bio and also in the description of this video. Click onto the link and you can watch a brief video about me and my background. You see this video on the screen here. In this video, I outline the style and the structure of my tuition. You can also read some of my reviews and testimonials from other parents and students who have worked with me on this website too. So if you feel like one-to-one tuition is something that would benefit you in order to get the grades that you need to get, then again, just head to this website. And what you can do is you can book a free 90-minute call with me. And in that call, we'll spend some time discussing you, your situation, your ambitions, what you want to achieve, the grade you want to get, and why you feel like you're struggling and why you feel like maybe tuition is the right path for you. And we'll also spend some time basically doing a free trial lesson where I will help you out for free with any particular topics or any particular areas of the syllabus that you know you need help with. And by the end of the call, we can then discuss whether one-to-one tuition is the right path for you to get you that grade you need to get. So once again, the link to my website is in the bio and in the description of this video. Now, let's go to part B. So for part B, find the distance of the bird from the nest when the bird first comes to instantaneous rest. So, I mean, if we go to our diagram, the bird is going to come to instantaneous rest at this kind of green position there, because when you are at instantaneous rest, that means your speed is 0. So we're looking for the position or the distance for which the speed is 0. So a speed of 0, a velocity of 0 means you are at instantaneous rest. So let's write this down here for part B. So for part B, we need speed equal to 0. So in other words, what we need ds by dt, so the gradient of our curve. So remember, s is the distance from the nest. So ds by dt, which is the gradient of the line there, to be 0. Okay, so we're going to differentiate our formula for displacement and then set to 0 and then solve for t. And then that will lead us to getting the distance that we need. Okay, so again, we know that the distance from the nest was 1 over 10 t squared. And then I think it was t squared. I need to remind myself what it was now. T to the power 4. Okay, what I'm going to do, I'm just going to expand the brackets there because it's going to make our differentiation easier. So this distance, let's just get rid of that there. It's equal to 1 over 10 t to the power 4. And then what was the next bit? It's minus 20 over 10. So minus 2t cubed for the next bit, minus 2t cubed. And then for the last term, it is 10t squared. Okay, 10t squared after we expand the brackets. So ds by dt differentiation, this is going to lead us to 4 over 10 t to the power 3. I'm just going to simplify that to 2 over 5. So 2 over 5 t to the power of 3. Then for the next term, that will give us a minus 6 t to the power of 2. And then for the last term, that will give us a plus 20 and then t. And we need to set this to 0. So set that to 0. Now, what we can do is we can factorize out to t, of course. But actually, before I do that, I think I'm going to just multiply everything by 5 because that will get rid of the fraction in front of the t cubed, because obviously we've got a coefficient of 2 over 5 for the t cubed term. So times by 5 everywhere. This gives us 2t cubed and then minus a 30t squared and then plus a 100t is equal to 0. In fact, what I'm going to do, I'm just going to divide everything in the equation by 2 now because we have even coefficients everywhere. T cubed minus 15t squared and then plus 50t equal to 0. Perfect. So now we can factorize out the t, as I was saying before, t and then t squared minus 15t plus 50 is equal to 0, like so. And then now what we're looking for, with this quadratic factor, 2 factors of 50 that add up to make a negative 15. So hopefully you'll be happy that the 2 factors will be t minus 5 and t minus 10, like so. Perfect. So what we have then is we have t equal to 0 or t equal to 5 or t equal to 10. Now, just from the graph, if we go back to our graph from part 8, it's kind of obvious that the time we need to get to this point here where the speed is 0 is 5. Okay, it's obviously not 0, it's obviously not 10, it's obviously 5. So we need to use t equals 5. That's the one to use. And we're just going to sub it into our distance formula. So now sub t equals 5 into s. So remember the formula as we've written up here is 1 over 10 and then t to the power 4. So that's going to be 5 to the power of 4. And then that is a minus 2, and then 5 to the power of 3, and then plus 10, and then 5 to the power of 2. Now I'm just going to use the calculator to work out what this gives us. So 5 to the power of 4 divided by 10. So this is 62.5. And then we have 5 cubed times 2. That's minus 250. And then lastly, we have 10 times 25. So plus 250. So this leads us to a distance of 62.5 meters. And that is the distance away from the nest when we reach our speed of 0 or when we reach instantaneous rest. Now, hopefully that does make sense. If you do have any questions, do feel free to drop a comment below, but otherwise I will catch you in the next video.